Connecting derivatives and integrals. There is a direct correlation between a derivative and an integral. A derivative determines the rate of change and how fast that rate of change is changing. An integral does the thing in reverse. Instead of going from position to velocity, we are taking the rate of change in velocity and determining the distance traveled. So, the derivative with respect to x d dx of the integral from x to a of f of t dt is equal to f of x. This means that the derivative of an integral is the original function. Another way to say this is the integral is the antiderivative of f. So if we're given the velocity function, say f of t dt, and we take the integral of it, we can then obtain the distance function, or the position function. If f is an antiderivative, capital F, then the integral from a to x, where a is a constant, or a number, of f of t dt is equal to the antiderivative as a function plus c, where c is some constant. The question is, what does that c mean and where does it come from? Well, when we take the derivative of a constant, it goes away. So then a single derivative can have many antiderivatives, where each antiderivative will have its own unique derivative. Let's talk about why that's true and how we get there. So if we let x equal a, which means that this is going to be this x is going to be equal to a, which we know that if we have the integral from a to a, it's going to end up equaling 0. So this is equal to f of a plus c, because this value a goes in there for our function, plus c is our constant. You get 0 is equal to f of a plus c, so c is equal to negative f of a. Thus, this means that the integral from a to x of f of t dt is equal to the antiderivative minus the antiderivative at a point. This is going to lead into the next section soon, the fundamental theorem of calculus. This is a very important theorem that will help determine how derivatives and antiderivatives are more related. Let's talk about how we're going to use this identity right here that we just shown to determine some integrals. So we're going to use this to determine the integral from 0 to pi of sine of x dx. First of all, I want to make the note that this is what we're going to be using. We're going to use that the integral from 0 to x, remember this was just a number, of f of t dt is equal to the antiderivative of x minus the antiderivative of a. Alright, so here we go. So what we want to do is take the integral from 0 to pi of sine of x dx. Now what we need to do is think about what is the antiderivative of sine. When I take the derivative of it will give me sine. Well, we know that the derivative of sine is cosine. And the derivative of cosine is negative sine. And the derivative of negative sine is negative cosine. And the derivative of negative cosine is sine. So if I write that out, I'm going to write sine of x on the side. And the derivative is cosine. And then negative sine, negative cosine, and then back to sine. This is if I kept doing d dx over and over. So I want to start at sine and I want to go up. Well, that's going to give me negative cosine. So I do negative cosine of the top value, negative cosine of b, minus negative cosine of 0. This value went there, and this value goes here. Okay, so now all we have to do is evaluate it. So then the negative cosine of pi is going to be negative 1 minus a negative Cosine of 0 is 1, so 1. And you get 1 plus 1, which is 2. And that's how you take a definite integral without using a calculator.